of attendance. Thank you for joining us today in the second webinar of the Bridge Black Sea webinar series that are happening throughout this year, and we are trying to convey the main actual results of the project, hopefully in an intelligible, easy way, easy to grasp fashion. So today we will be focusing on different technologies used in marine observations or different aspects of marine and maritime blue economy, but we will approach the issue from a more technological point of view, and we will feature many different things. Just so that you know, today I am Mustafa Yücel, by the way. I'm from the coordination team of Bridge Black Sea, and also one of the involved in many tasks, but also dealing with field trials of certain technologies. But today we, as a speaker group, we are representing a really big team, at least 100 scientists from 12 countries and 19 partners in 12 countries. They took part in what you will hear today in different tasks, in different field trials. The bridge project itself is, of course, much larger than this, but I just wanted to let you know that today you will be hearing about a fraction of what's going on. Hopefully, we will be able to demonstrate a variety of applications that we are developing in Bridge Black Sea. So yes, I will be doing an introductory speech first, giving you the main background knowledge on Bridge Black Sea and some of the challenges that Black Sea is facing. But before that, let's feature again our webinar series. So the name of our webinar series is called Bridge Black Sea Towards 2050. And this webinar series builds actually on the momentum of the bridge project. It's a product of the co-design process that's happening throughout many branches of the project. The first webinar happened in April, and it focused on the future of blue economy. A lot of work is going on a scenario building in the Black Sea that have been co-designed with hundreds of stakeholders across the Black Sea countries. And some of these scenarios were featured in this webinar. You can still access this online from our web channels and YouTube channels. But just wanted to convey you some of the bottom line. For example, the need to take action for Black Sea has been a very common theme in our stakeholder engagement activities, such as nutrient input from land-based activities need to decrease, fishing activities need to be reduced, protected areas need to be implemented, and they need to be diversified. And most important, maybe, or also connected to today's webinar, is social and technological innovation is a must for a more sustainable future. Of course, today we will be more maybe focusing on technological innovation, but social innovation will be also very important. So today's webinar too, and our upcoming webinar will be on the Black Sea Digital Twin Ocean demonstrator that we are building in the frame of Bridge Black Sea. In a way, both webinar number 1 and webinar number 2 are going to be components of this demonstrator. There are many other components as well, and you will be hearing about the DTO demonstrator in September. Stay tuned for the exact dates and registration links. Today, we will be mostly talking about ocean observation, marine observation, and when we look at a map of the Earth or the oceans, especially nowadays, there are many different digital applications that you can actually visualize many different data. And of course, those tools and those images are great. They give many of the ocean properties in very high resolution. But that also gives an impression, especially for the uneducated or not so ocean literate, let's say, especially for those, it can give the impression of a two-dimensional ocean. But actually, oceans are three-dimensional, and this depth dimension is not easy to maybe convey in science communication, but at least it's there, and then it has a huge impact. The depth dimension, the third dimension of the ocean, it controls actually the planetary climate, represents the largest habitat on our planet, helps recycling pollutants, helps deep sea, especially the ocean interiors, helps storage of carbon, etc. So, and it's not easy to observe, it's not easy to generate data to inform models or to inform different tools. And that's in Bridge Black Sea, we have taken several steps towards this, as you'll hear. Of course, many different tools and monitoring technologies have been developed already. I mean, it's not that we are starting from scratch, especially considering the surface ocean, which is anywhere from a few meters to maybe 100 meters below. Many tools are already available thanks to remote sensing or aerial aircraft measurements. So now drones are also becoming more and more prevalent, or shipboard measurements. So we have a relatively good understanding of the surface ocean, and now we need to replicate the success to the rest of the ocean. On the right, you see a image of the satellite image or satellite-derived product, data product from the Black Sea, showing the productivity, the chlorophyll A concentration, which is a proxy for productivity. Productivity here meaning the production of organic molecules, this biological production of organic molecules using light, and certain photosynthetic organisms, they can do this. And nowadays we have access to these sort of data products very commonly on a daily basis, sometimes even maybe hourly, weekly basis, depending on the product. But just to remind you that these sort of products, they are great, but they can only inform us on the top layer of the ocean. The average ocean, world ocean, is 3,800 meters deep, and Black Sea is also quite deep. The deepest point is around 2,200 meters. We especially need tools capable of withstanding the specific Black Sea conditions, not only depth, but Black Sea has additional specificities. It's unique in the world, for example. It's the largest oxygen-free and hydrogen sulfide containing sea basin. So any technology or any observing platform or any robotic or moored platform you are developing needs to withstand these sort of harsh chemical conditions. So it's one of the specificities. The Black Sea also has a strong salinity gradient, which translates into a very sharp density gradient. Here you see some of our expedition results from the Black Sea. In the left panel, you see the depth in terms of pressure and the potential density anomaly. This is just to show you that the top layer, of course, depending on the season, the thickness is different, but it has a very different salinity and density than the deeper layers. So Black Sea is also very specific in terms of this strong density stratification, which has implications, of course, in terms of design of, for example, any robotic mission, such as glider that we will also briefly mention. So any technology, any sensor, any platform, any monitoring platform that you are developing needs to take into account these sort of features of the specific features of the Black Sea. So back in 2017, considering these specific features, but also many others and many other also additional needs on blue economy and innovation needs, an initiative was set up led by the countries of the Black Sea and European Commission on the Black Sea blue economy. And in the day, this was called the Black Sea Blue Growth Initiative. And in a couple of years to 2019, this initiative came up with the Black Sea Strategic Research and Innovation Agenda of the Black Sea, outlining all these challenges, highlighting the specificities of Black Sea, and then proposing actually priority actions on research and innovation. Based on this, an implementation plan was also launched in 2023, but before that, two projects, again funded by Horizon 2020, was funded, Bridge Black Sea and Doors Black Sea, the two sister projects. And before those two projects, the Black Sea Connect Coordination Support Action was also funded. So this, the initiative and this, let's say, the wind that actually came from countries, the strong encouragement led to a really intensive research and innovation activity in the Black Sea region in the past 6 to 7 years. One of the culminating moments of this effort was the 2023 launch of the Black Sea Strategic Research and Innovation Agenda Implementation Plan in Brussels. And also stay tuned because Bridge Black Sea will have its final event in Brussels as well in late November. So also stay tuned for this. We will be doing a similar event, but we will be building on our last Brussels event, hopefully with the participation of the country representatives as well. So the Syria process was quite active, and in the implementation plan as well, one of the recommendations that needs to be, as a team, that needs to be implemented in a relatively urgent fashion, it was on innovative observing systems. So that's one of the reasons why we are also organizing this webinar on this theme. Just a couple of basic facts on Bridge Black Sea project. There are 31 partners in the project from Black Sea countries, but also from different countries in Europe. 31 partners, and total budget is 9 million euro. So when it was funded, it was a Horizon 2020 project. Now, as you know, we are in Horizon Europe, but it was funded as a part of Horizon 2020. One of the aspects of Bridge Black Sea, of course, we have this holistic basin-wide approach. And not only the sea basin, we are also considering the surrounding lands. We are really working hard on quantifying different inputs from lands, also from atmosphere. And we also focus on the sea as a whole, but we have this huge also focus on regions, on really localized sites called pilot sites, and there are 6 of them, and we focus on certain preeminent multiple stressors or key ecosystem services specific to that site. And all these issues were also co-decided with the local stakeholders. So this is one of the aspects also guiding our innovation and development activities, which more concentrate on the second node of the project called Blue Growth Incubators, and maybe clustered around 2 work packages, 5 and 7. As I already told you, the work that you will be hearing today is really a product of many different teams. So over 100 scientists in 12 countries. We have conducted joint research expeditions. We have shared methodologies, shared our data with each other and with the rest of the world. But maybe more importantly, we have already raising a new generation of young scientists with different skills already. They have been a big part of this of the work, and they have been driving the work forward at the moment towards the end of the project. Long story short, the project focused on 8, let's say, technology packages, and we have organized them into 2. The first group is called Smart Monitoring Systems. So things such as Glider and Scanfish, these are more robotic or semi-autonomous observing platforms. Benthic observing systems, eDNA metabarcoding, and metagenomic-based enzyme screening. So we have packaged them as smart monitoring. These are ways of cost-effective observing the oceans in a cost-effective and rapid manner. In the second division, we have new sensors and tools. These are more specific technologies and tools designed to measure a specific parameters such as species of phytoplankton, PCO2, pH, radionuclides, hydrogen sulfide, or detecting mammals. And you will be hearing, actually, in today's demonstrations, you will be hearing 3 of these specific systems. But on the smart systems level, we have actually increased the level of adoption of these systems in the Black Sea to our activities. For these systems, we have not used a technology readiness level scale, which we use for the other division, but we have implemented a level of adoption, a simple scheme. For example, with regard to eDNA metabarcoding, which is a very new application in the Black Sea, we conclude that we have now raised the application of this methodology to a medium level, but there is still room for progress. But when you look at things like Glider or Scanfish, which one of the first deployments in the Black Sea happened in Breach and Doors projects, by the way, maybe the first, I think we can easily say the Glider deployment was the first. We think that now these type of systems are highly adoptable. I mean, they are ready to be upscaled, and we will touch upon these issues later on. On the other hand, on the eight technology components, let's say specific sensors and tools, here you see the level of technology readiness steps that we have implemented throughout the project. So the blue arrows are what we achieved during the project, and the gray arrows are where we actually started in the beginning of the project. We are not starting anything from scratch, but for some of the technologies such as phytoplankton, digital libraries, underwater radionuclide detection, unmanned aerial vehicles for jellyfish, etc. For these sort of things, we have really pushed the TRL levels to really mid 5 to 6 levels. For other technologies such as in situ PCO2, pH, or acoustic MAML, they were already kind of mature, but we have brought them one step closer to flight readiness, basically, in terms of NASA jargon. All right, so today we will be demonstrating you these ideas, but on a broader innovation, let's say theory or application, this technology readiness levels or technical side is only one aspect of the issue. There are different, one can speak about different readiness levels, funding, team, intellectual property rights, business, and customers. You need users as well, right? So in Breach Black Sea, thanks to VP7, we are analyzing all these actual aspects in a holistic manner. The idea is to go from proof of ideas to proof of concepts to proof of businesses, so things can be upscaled and accelerated. For this, actually, we have already deployed a Black Sea accelerator program, and we have organized high-tech summits, and we have already demonstrated the big potential of the Black Sea in terms of there are many different developments going on, but of course, things need to be integrated, accelerated, and then upscaled. All right, with this, let me give the floor to my colleagues that will be presenting the demonstrator cases. But before introducing them, I think, Pınar, we would like to do a poll, right? A short poll now that we have over 90 people.
Yes, exactly. Just to get
Yeah,
to
we have a very short poll
better.
so we can gather some metadata about you. Yeah, so which country you are coming from and your profession, very simple. So are we going to look at the results now or maybe later?
Yeah, the results are still coming in. I think 70% of the participants have filled it in. I can, yeah.
Yeah, this is just to a little bit think about, for us to think about the discussion part. So what sort of questions we can expect. And
Okay, I'm just gonna share the results while I'm sharing the screen for Carmena.
so mostly from research and academia, but there's a good deal of national administrative people, NGOs, civil society, and blue economy operators, mostly from companies and industries. Thank you. And we have a quite bit of participation from outside Black Sea, which is also great. Can you still see my presentation? Yes.
No, I just stop your screen.
Yeah.
Okay. Just let me briefly introduce.
Yes, go.
We should reshare again and briefly introduce our speakers. Can you see it now? No?
Not yet.
Okay, sorry for that. How about now?
Yes, we can see now.
Okay, so yeah, I'm very happy that today my colleagues are joining me in this webinar. So Kremena Stefanova, with whom I had a very big pleasure to co-lead Work Package 5, she will be highlighting the rapid jellyfish detection technology that they are developing in IOBAS. Nina Zembekova from IOBAS as well will feature smart phytoplankton monitoring through a wave of technological innovation, also digitalization of a database, which is important. And Agatha Laes from IFREMER, we are very happy to have IFREMER and her team actually in the project, and they will be featuring one of their high advanced applications of pH sensing in the Black Sea. And after them, we will be more moving into a discussion on upscaling and acceleration of these technologies. So Matteo Bocci will be leading the presentation, but he will be joined by Fredrik Herpers, also from Strategies Mare and Littoral, and Patricio Mariani from the Danish Technical University. I thank to all of them once again for their willingness and for the preparation for this webinar. And with this, let's move to our first demonstration case, rapid jellyfish detection. So Kremena, the floor is yours, and I will stop my screen.
Pilar, if you'd like, I can. Okay. Thank you. First of all, thank you for your participation and attendance at this webinar, where we will present one of innovation tools for rapid jellyfish detection. Every year, especially in summer, jellyfish bloom across our coast. Until recently, monitoring is jellyfish population is very high, and we try to monitor through the routine methods, and unfortunately, these data are mostly irregular. What is important? Why jellyfish? Because they are attracting our attention and our due to dense aggregation, especially in the coast area. Also, monitoring of jellyfish is very important, crucial for maintaining of balance of food web, and that's why jellyfish is very important in our monitoring strategy. Please, next. And actually, first we try our concept to present our concept. We focus on developing, testing, and implementing a methodology for monitoring in the Black Sea, along the Bulgarian coast, through the air and underwater. New technology. We use the drones. First, we put forward several questions like, can drones detect and quantify jellyfish blooms? How reliable are drones, and what are the optimal technical parameters for aerial and underwater jellyfish monitoring? What are the benefits from this limitation and compilation combined to underwater and also aerial technology for vertical and also spatial jellyfish distribution? Can machine learning improve jellyfish detection and reduce post-processing time? And that's why we know that pilot studies occurred and concept papers exist, but for the Black Sea it was new, and we tried to adopt for our area and for the Black Sea. Please, next. Our main goals are related to develop and validate an innovative non-jellyfish monitoring system for the Black Sea, to establish standard protocol for drone-based photogrammetry and to image analysis. Also, to assess reliability of the new methods and conduct seasonal drone mission across Bulgarian coast, and to find how the achievements support local authorities, local fisheries, and aquaculture and tourism. Actually, to demonstrate operational visibility and accuracy across coastal zone, and integrate results for early earnings early warning systems and policy relevant management tools. Next, please. We use two platforms that to detect jellyfish aggregation through the aerial drones, and also to try to find what is happened in the water column using two main platforms like underwater drones and also acoustic vehicles. Please, next. Our first principal object was to conduct test flights for unmanned air vehicle. First flight, we tried to use 5 different meter from 10 to 50 meters to find the best option for monitoring of two medusa species, which are the main species in the Black Sea. Based on the test flights, we recognized and understand that from 10 to 20-meter altitude above sea level was defined as a appropriate flight for Aurelia, but for the Rhizostoma, 25 from 30 meter was the good point for the flight of and detection of Rhizostoma. The next, please. Here we'll see the main steps of our process. First, flight trajectory and mission design, and a zigzag polygon over this polygon transect in the selected area located where the monitoring was done. After each aerial survey, a number of overlapping photos are stitched, and using Agisoft orthophoto mosaic generation were occurred and design this for orthophoto mosaic photos. After that, we select the area to perform the jellyfish detection using image post-process with QGIS. After this area was selected, we pre-process and automatically detect and counting image through the image J, and counting all species we were identified in, and also individuals. Next, please. According to underwater drone, also the same technique overview we'll see. Mission design for underwater drone, mission complements through video footage record and post-processing of video records. According to underwater acoustic detector, first evaluation of sonar solution were established. Also after that, development of sonar system, supporting system, field trails for jellyfish detection system at longer range, and in the end, evolution of collected data for jellyfish detection. The next, please. Here we'll see our first results. Two main location we monitored close to Varna, and another is Kaliakra area. Here in Zelenka, in Kaliakra area. Aerial surveys were carried out from July 2023 to November 2024. In a total of 65 flights were done, 34% of which were identified with Scyphozoa species. For data validation, you will see now in the plot how all steps were passed through the process. After the flight, we organize orthophoto mosaic. After that, when aggregation is selected, we cut the area with aggregation, and after that, one is the very important point is to select and make the picture in black and white to in this process is very important to detect and count jellyfish. With black and white, actually jellyfish are how to say, they are presented in white, and we can count very easily. After that, this selection, we try to validate data with manual counting of the species, and the date validations really were very promising because of actual automatic counting and manual counting present very similar results. Next, please. Another demonstration results were also interesting for how to detect biomass. Due to the process in the Agisoft, we try to, the program give information for area of each individual according manual of macrozooplankton for Black Sea area, and also according to some equation which exist, we try to find on the base of the area identified diameter of each species, and on the base of this diameter to find the weight of each species, and then to finalize what is the biomass of jellyfish for this monitoring date. On the basis of this measure, we identified according to our results in July about 1.50 kilogram per square meter for Aurelia, and also for Rhizostoma a little bit more, about 50 kilograms, 1.50 kilograms for Rhizostoma. Here we can see the results from underwater drone. Surveys were carried out in shallow waters, about 6-7 meter depth. Over the course of 1 year, we had missions, 40 missions were conducted, and two approaches were selected for use and identified species and to count. One is approaches is video navigator software. This software actually is for benthic records, but we adopt for the jellyfish. This software is freeware, developed by Institute of Marine Research in Norway. The tool for gelatinous species, the second one was Agisoft also, but what I wanted to say here, very important, that with aerial drones we cannot detect invasive species like Meneopsis and Beroe, but using ROV, using underwater drones, this very easy to detect and very easy to select and count these two species, which is very important for monitoring and for marine strategy directive indicators. The next, please. Here you'll see bloom of Aurelia when was detected in November 2024. Here we see how it is navigator used, and the jellyfish are counted, and this information in the end give us the picture of the situation and what is the special spread of this species. Next, please. According to acoustics, this was presented and worked under the GTO Institute. Here, it is important to say that two echo sounders were evaluated. One is a coolest from Blueprint Subsea and the blue view from Teledin Marine. Between 2023 and 2024, two prototype sonar support systems were developed. The system actually demonstrated and was ready to be used in the Black Sea, but actually for the moment it can say that work well in the simulated waters, very similar to Black Sea. The next steps will be to try to do in the Black Sea waters acoustic monitoring. According to disadvantages of this, of course, all programs, all systems exist some advantages in and pros and cons, but I wanted to say that WAF give very good information for high resolution imagery, cost effective for long-term monitoring. Also, this is a non-invasive process and real-time data collection. Very important also for the ROV that high resolution video images appear, real-time observation, also long-term investments for repeated use across multiple projects, and frame extraction enables photogrammetry in details analysis. Of course, what is not good for this tools that these are influenced by the weather, and they are now used just for the coastal areas. We need to develop in the deeper water as well. The next, please. Why it is what we can say that we learned more about where jellyfish distributed and both across the sea and different depths. And also we found smart ways to monitor them without always needing nets and boats. Also, we are moving closer to fully automated and to deep learning for marine research tools. Next. Actually, when we start, we wanted not to put forward only scientific aim in front of our work, and we wanted to know who can use these tools and why it is important. This information can give info for early alerts to jellyfish blooms, for tourism, for real-time detection, also for agency of environmental agency and policymakers, especially in evidence in Marine Strategy Framework Directive monitoring, and of course public engagement with this visual drone data support citizen education and awareness. Next, please. Also, we can say that first, our work aligns directly to major AU priorities like Green Deal, because we doesn't need to use boats or ships. Also for biodiversity strategy is important, and for Marine Strategy Framework Directive. We think that it's possible to use in another fields of investigation. For example, for marine litter could be used also in another areas, and this support transboundary monitoring framework and our work in the Black Sea Commission. The next, please. If we need to summarize when we start in the beginning and what happened, we start with basic manual jellyfish observation and move towards advanced tool like development, not only research but in development, and we try to test and implement in the waters. What we need, of course, we in the middle of our work, but very promising our results. What we can see more that this shift from prototype to real world deployment, and this is key for to transformation, how we monitor the Black Sea, bringing us closer to fully automated operational system, what we need to be our next steps. And next we aim to boost artificial intelligence accuracy to go deeper with drones and better link aerial and underwater data to get there. We need some better some education, skilled teams and strong cross-border collaboration with colleagues from other institutes. In conclusion, in the last further, we can say that now we in new era of jellyfish monitoring with new devices, new tools, and we can say that their flexibility or automated potential and ability to access remote coastal areas make them very valuable for our monitoring in the future. Thank you for your attention. And
thanks a lot, Kremena, for your excellent talk, and thank you also for highlighting some of the work done by Technical University of Denmark on their underwater detection technology via acoustics. But it's great that you both really closely collaborated on this to come up with a joint perspective. If you have questions for our participants, if you have questions, please note them in the chat for the moment, and after in the final phase of the webinar, we will review all of your questions and jointly discuss them. So let's now move to our second demonstrator case. Now we will be moving a little bit. We started with jellyfish, which are visible and relatively large. We will go another class of biological organisms called phytoplankton. They are more microscopic and smaller and challenging to detect, but Nina and her team has a new way to go forward for the Black Sea. So Nina, the floor is yours. Yeah.
Thank you, Mustafa. Do we see the presentation?
Yes, we
Yes.
can.
Yes.
Thank you. Thank you very much. Thank you for the nice introduction. And actually, we really stay in the plankton and in the smart monitoring. But as Mustafa says, this time we will focus on phytoplankton. What is phytoplankton? Phytoplankton or microalgae are microscopic photosynthetic organisms that inhabit aquatic environments. They are highly diverse, including groups like cyanobacteria, diatoms, dinoflagellates, green algae, and coccolithophores. About 5,000 species of marine phytoplankton have been formally described to date. And despite their tiny size, they are actually really, really important on Earth systems. They form the foundation of aquatic food webs, and as such, they support the life in the global ocean, from the microscopic zooplankton to the giant mammals like whales. They contribute about 50% of global oxygen supply and play a key role in the biological carbon pump, transferring about 10 gigatons of carbon dioxide annually from the atmosphere to the deep ocean. and even small changes in their abundance can influence the level of carbon dioxide in the atmosphere and consequently the global temperature. Additionally, some species are related to toxins, foam forming, bad smell, or biodiversity loss. And in most of the cases, this is related to an excessive growth of these algae in water bodies, or a phenomenon known as harmful algal blooms. Between 100 and 200 species are considered harmful, from which about 80 are confirmed toxin producers. Toxic blooms cause illness and death via toxin transfer through the food web, while non-toxic blooms cause damage due to the high biomass, shading, and oxygen depletion. So it is not surprising that both phytoplankton biodiversity and harmful algal blooms are included as key indicators in the Marine Strategy Framework Directive. Given this really serious negative impacts on human health, ecosystems, and economy, it is really crucial to have an effective monitoring program to prevent or mitigate this negative impacts of the blooms. What happens in the Black Sea? Till now, the Black Sea have been spared from major toxic events, but the phytoplankton blooms have been considered a key ecological problem for the health of its ecosystems, especially during the period of intense eutrophication. More than 30 potentially toxic species have been reported in the Black Sea till now, with various phytotoxin found in mussel samples and in plankton samples. Considering also the worrisome trend of global warming and warming in the Black Sea particularly, we need to think about the importance to have really effective regional monitoring program, which to be adapted, as Mustafa explained in the beginning, to the specificity of our basin. Traditionally, the phytoplankton monitoring in the Black Sea is based on microscopy taxonomic identification, which is done under light microscopy. Of course, as each method, it has its strengths and limitations. Among the advantages are the possibility to direct observe the cell conditions. It can be used in the field. One of the most important thing is that it has really well standardized protocols, and its long-term use makes the data that is obtained comparable with historical ones. Among the limitations are time-consuming and labor-intensive methods. It needs taxonomic expertise. It really takes many years one person to be trained enough to have the confidence to be an expert taxonomist for phytoplankton. It also has limited sensitivity for some cells, low discrimination among some species that are morphologically similar. And also, usually the samples are preserved, which sometimes lead to degraded quality of the sample. And after that, some cells cannot be identified. So to help overcome some of the limitation of the traditional approach, the recently developed technologies give some options for us. And one of these technology is imaging flow cytometry, which offers high throughput and automated detection with really rapid processing of a large number of cells and the possibility to continuously analyze sample. It offers also image-based identification. We can obtain quantitative and multi-parametric data because it can measure size, shape, fluorescence, and pigments. When the process is automated, it of course reduces the human bias. And also some of the instruments can be field deployable and operate autonomously in situ. So one of the most frequently used imaging flow cytometers is actually a CytoSense instrument. What CytoSense do is to record multivariate data from individual particles or cells. So this level 1 data actually consists of the optical properties of the cells, which are its forward and sideward laser light scattering and its fluorescence. In addition, we also have a monochromic photo of the cell. And combining this data, when all the properties are recorded, because during the analysis everything is recorded, we can further classify or group these cells based on their properties like size, structure, shape, or fluorescence. If we go further and have a library, we can categorize the cells into taxonomic categories, for example, species or genus level, depends on our library. And some of the key specifications of the CytoSense that I just would like to underline are the unique particle size range, because it can analyze particle with the size between 0.1 and 800 micrometer in diameter. And for the length, it is even more impressive, 2.5 millimeter size, which is very useful for filamentous species. Also, it has modular design, so it can be configured according to the user's needs, and it is upgradable. Talking about level 2 data or library, we can mention the very important part of the process, which is the classifiers, the automatic classifiers. So EasyClass is software developed especially for automatic clustering of CytoSense data. It groups the cells from specific algae types based on their particular signal profiles, and the results can be further validated through the images of the cells. And all these groups with similar properties, so-called fingerprints, are stored in the database. What is really crucial for this software is that it enables users to build their own library specific to the phytoplankton community in their area of investigation. And after that, users can apply them as a training set for the rapid automatic classification of the species in the analyzed samples. So it is really important to have this such a regional data set for accurate and precise identification and classification of the species in your region. So what we have done within the bridge was to utilize of the already established technologies like CytoSense and plus EasyClass, but to develop such regional data sets, which actually is the most labor-intensive aspect of the whole process. And it was done in line with some of the specific objectives of Bridge project, and more specifically Work Package 5, within which the development of a regional Black Sea phytoplankton species image library was initiated. The data for the library was gathered through numerous samplings in Varna Bay between June 2022 and June 2023, with the aim to cover as many species as possible by obtaining at least 50 to 100 images for each species, because the images are really, really crucial, and the classification is really dependent on these photos. The live water samples were processed in the lab using, as I said, a CytoSense instrument as fast as possible after the sampling. And only high quality images that could be reliably identified and labeled were manually selected and included in the database using the EasyClass software tool. The annotation was done by my colleague Natalia Slobakova, which is an expert taxonomist from IOBAS with more than 20 years of expertise in this field. So the identification is really reliable. And most categories and that were redefined are at the species level, but of course not all of the cells of the taxa allows to be precisely determined to the species level. So they were left, some of them were left at the higher taxonomic level. For nomenclature, the taxonomy follows a world register of marine species. So after many hours from my colleague Natalia Slobakova, finally we had more than 8,000 photos curated and included in the Black Sea Image Reference Library, which encompass 160 taxa, from which 49 genus level and 111 species level. You can see here some example images from 18 categories that we have in our library. Of course, it is just a small example, and only one photo was picked for the presentation, but below each image there are many more images from different angles with different cells in order to have a really rich database. After having this library developed till some stage, of course, we needed to evaluate its performance and the performance of the classifier using the library. So we selected 72 samples from the same sampling stations and analyzed all the samples through the same pipeline, which was the settings was chosen by my colleagues Natalia Slobakova and Violeta Slobakova, which actually are the main people below all this work. And having these 72 samples analyzed, we obtained between 61 and 122 clusters, which corresponded to 58 to 118 taxa at the genus and species level. We were happy to have a high average success rate with about 78% of the cells successfully classified into one of the predefined categories. Here on the slide, you can see one of the samples and how it looks after it is automatically classified with many species here identified, and here it is visualized like clusters and how they look with their rough optical and fluorescence profiles and with their photos. To further evaluate the performance of the approach, we compared the results that we obtained from the image rank flow cytometry with the traditional, we can say even reference, light microscopy protocol, analyzing the samples that were collected in parallel with the samples analyzed with the other approach. So what we obtained as results, we had really more species identified through the traditional approach, through light microscopy, 224 species, while with Cytosense we obtained 106 species. But for the other indicators, the Cytosense demonstrated better performance. For example, greater sensitivity in terms of average number of taxa per sample, 89 for Cytosense versus 69 for light microscopy, and also really impressive better performance for the time for analysis. For the Cytosense, it's took about 20 minutes per sample, while for the light microscopy, even really experienced taxonomists like my colleague Natalia Slovakova, the analysis of one sample takes about 8 to 10 hours, which is really, really long time. So having this result, we were really optimistic that there is a real potential to use our library and our approach for operational monitoring. Of course, the library will continue to be expanded with new species added and additional images of the existing taxa also to be included in the library. One important step for the further progress is to validate the library for quantitative assessment of phytoplankton composition, which is an important step toward effective harmful algal bloom monitoring and developing of early warning system for ecosystem and health protection, because currently we can use it only for presence absent data or relative abundance data. And in order to have precise threshold, we need to validate it against the traditional approach. And some possible end users that can benefit from our work are the regional environmental agencies, marine researchers and ecologists, aquaculture industry, drinking water utilities, and regional authorities that are involved in port and ballast water monitoring. And problems that this approach can help be solved are early detection of harmful algal blooms, prevention of shellfish poisoning, lack of taxonomic expertise, as I explained, it is really crucial, slow data turnaround, and also ballast water contamination. And I would like to finish my presentation with a real example case to see that actually people has already utilized this approach in reality, in a real field. This is a water quality monitoring field station in Lake Taihu in China, where the basin authorities use it along with other sensors to do real-time monitoring, and the Cytosense is used particularly for automated assessment of the abundance and population dynamics of a toxic cyanobacteria, Microcystis aeruginosa. And thank you for your attention.
Thank you, Nina. Yeah, the vision you actually highlighted in the end is really very relevant for Black Sea. Because most of times when we think about ocean observation, we think about the temperature, salinity, maybe oxygen, and currents, but one of the things Bridge is proposing is that now several technologies are becoming mature to be packaged in such offshore monitoring stations, also recording phytoplankton diversity, jellyfish, and sampling for eDNA. So in our project, I think we are providing many different components that can contribute to such future observing systems in the Black Sea. So with that, let's move to even smaller entities of oceans, so molecules and chemical things. And Agathe Elias from IFREMER, we are very happy to have them in our project, and she will be presenting the case of very, very sensitive, hard to do pH measurements in the Black Sea in situ. So Agathe, please, the floor is yours.
Thank you. Can you see my screen? Is that
Yes.
okay? Okay, great. Well, many thanks for the invitation. It's a real pleasure to show what we have done so far on the pH sensor application in the Black Sea. You probably all know the importance of ocean acidification monitoring, as the pH is considered as a subvariable of the inorganic carbon essential ocean variable, the EOV. So understanding and predicting pH variation with accurate and certified in situ detection over the long term and on large spatial scales is really essential. So for that, today we have autonomous pH sensors that give us the ability to observe and to better understand the ocean. And I'm going today to make a focus on the Black Sea ecosystems, which are, such as other parts of the ocean, under growing pressure of climate change. So for that, we purchase pH total sensor called the SAMI pH from Sunburst Sensors. So it's a colorimetric method. What it's doing is that it's pumping the seawater as well as an indicator, the meta-purple crystal, and it's pumping through the mixer and then going through a flow cell in which the variation of the coloration is going to be recorded. As you can see on the left, there is a photograph of the variation of the coloration from yellow for acidic waters towards purples for pH water closer to what we can find in the ocean. So what we have done first was a calibration test using this coloric SAMI pH and also a colorimetric method, which was a reference method in our metrology laboratory. So we did an intercomparison using natural seawater as well as a Guillaume standard. And what we could find is that there was always a little difference between the reference method and the SAMI pH, but it was giving still a good precision. And so we carry on with in situ test trials in Brest. It was between 2022 and 23. And we performed in two in situ environment, one in the seawater tank, and other one in at the bottom of a tidal tower. And then we perform in entire comparison again in the metrology lab. And then I'm going also to show you what the results we have obtained during a shipboard testing in the Black Sea. So just to start, we have put our system in a seawater tank, and it was during May 2022, during 3 days, and the sampling frequency was every 15 minutes. So what we can see on the graph, just on the right, is variation of the pH as a function of time. And what we can see is that the pH is also varying as a function of day and night cycle, probably due to physical processes, exchanges with the atmosphere, and also thermal effects, as well as biological processes, such as photosynthesis and respiration. We also deploy our sensor at the bottom of the tidal tower, and this was performed during 6 days, and the sampling frequency was every hour. And what you can see on the graph, and so in blue we have the pH variation, and in orange it's a variation of the temperature. So there is still pH evolution as a function of a day-night cycle, but you can see it's more messy than before, probably because the sensor was immersed in a more contrasted area. But there is also probably biological and physical processes acting concurrently, but varying in proportion as a function of time. So the sensor was working pretty well in situ. So we wanted also to intercompare this SAMI pH with the same reference methods as I have exposed before, but also with a CFET sensor, so from a Seabird scientific company, and is based on electrochemical method. It's not a colorimetric one. And we also wanted to test it against the CFET because it was one of the sensors that was going to be deployed during the cruise in the Black Sea. So here you can see the variation of the pH as a function of time. So in yellow, we have the spectral reference method. In gray, we have the CFET that is varying. And in green, we have the variation of the pH obtained by the SAMI pH. So I have to tell you first that the CFET values were corrected from the spectrophotometer at the beginning of the test. What we can see is that the CFET is giving a highest response time compared to the SAMI one. And what we can see also is that the pH values from the SAMI are again stronger than those of the reference method, but it was not corrected as the CFET was corrected. So then we were able to go on the cruise on the BLIM 2 during July 2024. And we tested 3 different sensors. So they were, for 2 of them, for the CFET and the SAMI pH, they were immersed into a seawater tank. And there was a seawater supply coming in front of the optical cells of the CFET and the SAMI pH. And we also add a 3rd sensor that is a homemade colorimetric sensor from the IFROMER. That was just the water was flowing into the system. It cannot be immersed yet. And so the SAMI, the CFET were collecting values. The Phoenix was also collecting values, and it was considered as a reference method during the cruise because we did some metrological evaluation during 2 European projects using this sensor. It was a MINCE and Safeties project. So the results, what we can see. On the left side, you have the variation of the CFET values. Without is a correction, it's on the left, and with the correction from the Phoenix correction. You have to know also that the CFET, SAMI, and Phoenix were corrected. The 3 sensors were corrected from the salinity and temperature coming from the thermosalinimeter that into which the seawater supplies was flowing into. So what we can see is that for the 3 sensors, we have the same values with the highest pH values obtained at the exit of the Bosphorus Strait, and it was extending in a northeasterly direction into the Black Sea. The lowest values were obtained in the northern part of the transect, but also in the Marmara Sea. So what we can say that is that there is a complementary of the high frequency of the CFET, which is really interesting, and also with the 2 colorimetric methods that were used to correct the CFET sensor. This increase in the pH could be related to a maximum value and in the total chlorophyll A, but also in ammonium and in dissolved oxygen values. And this was supporting the hypothesis of probably a phytoplankton bloom occurring in this part of the Black Sea. We also perform some cast measurements, and for that we implement the SAMI pH on the rosette. You can see it on the right photograph. And we also wanted to see that if there were some variation between the SAMI pH and the pH coming from the CTT. And so there is a variation of the pH values as a function of a transect from the point A to the point B, and this as a function of the depth. And what we can see is that we have nearly the same values. The SAMI pH is really consistent with the pH values obtained from the CTD. And again, we had the highest pH values obtained near the Bosphorus Strait, confirming the transect observations that we did before. So to conclude, it was the first time that SAMI pH was deployed in the Black Sea, and we could obtain a TRL of 8. So it was really interesting to see that this type of sensor can give really accurate values, even if it was a more enclosed sea. We did some valorization of the results. Remy, who is on the photograph on the right side of the photograph, was able to go with Romain on the workshop Paul Quasimem that at the NOC, and they were focusing on the quality assurance of for inorganic carbon system measurements. We also were able to go on the One Ocean Science Congress in Nice in June 2025 to show the results. For broader application, the study of the pH variation could be done more widely in the Black Sea, and probably also at different sampling seasons. And but would be great if it could be done over several years. The SAMI pH, what we could say is that alone it is probably insufficient to increase spatial and temporal covering of pH mapping. The sampling is much lower than the CFET, and the depth, it can only go until 600-meter depth, which is not enough for a wider covering of the pH mapping. However, it gives a good precision and good accuracy that is necessary for a good estimation of the pH variation, which sometimes the CFET does not give, probably because it is an electrochemical sensor and it has tendency to drift as a function of time. So mainly what I think the main point is to remember that the importance of calibrating any type of sensor against a reference method for incorporation into models, particularly for long time series. The possible end users can be the ocean acidification research communities, as well as the government environmental monitoring agencies. Industrial application could also use this system, but it's still a niche and competing market for ocean acidification. For the broader policy implication, of course, monitoring and assessment, identifying vulnerable ecosystems, and evaluation of mitigation strategies. And just as a reminder, recently GRAB has published some main trends that we have to focus and to think about. There is a need for both training and funding for ocean acidification to make a significant impact on research capacity. And there is a need of continuous investment in order to sustain the workforce, to maintain equipment and calibration and intercomparison in order to support ongoing research and monitoring. And that's it for me. And thank you very much for your attention.
Thank you, Agathe, once again to you and Remy on this wonderful work. Yeah, and thank you also for highlighting number of end users. As you might have realized, we have selected our demonstration cases. Yeah, they are different and they cover different scales of observation, but also they represent, or their target end users are also, of course, there are overlaps, but different. For example, with the jellyfish monitoring, maybe there can be some interest in local bases or local authorities. But when it comes to something like a very high precision pH monitoring, there is a great need in the context of the users that Agathe mentioned, from IOC all the way to new emerging digital twins or this global ocean observation databases. So we hope that we were able to give you a glimpse of what Breach Black Sea is trying to accomplish in the context of Black Sea monitoring challenges. So with this, without further ado, let me give the floor to Matteo Bocci from our work package 7. As I said earlier, you can still add your questions to the chat. After Matteo, we will visit your questions and start discussion. Matteo, the floor is yours.
Yeah, thank you. Thank you, Mustafa and all. And again, compliments for the great work and fantastic presentation. It really, I mean, helps me a lot to passage the message that I want to give here as well. And from that angle, a different angle of the bridge project, where we look at the kind of blue growth incubators and together with work package 5 and 6, in work package 7, we really look at acceleration of business model and solution. And as you said, we work in different areas. We promoted this regional platform of innovators, this high-tech summit for the Black Sea. Every 2 years, we had a very interesting large event. Then we look really at promising business models and how technology can be an enabler to those. But then we together with Bridge and Doors, promoted the Black Sea Accelerator, which is what I'm representing in here. And now we're trying to really look at this recommendation and way forward to really scale up a solution and look at what works and maybe what still doesn't work in doing that. And maybe because you got so many nice things of what works, I'm being a little cynical here and pointing the finger of stuff that should be still done to allow for technology to really scale up and be uptaken by end users, as you all point out. That has been already presented, but just to say that, as part of our working accelerator, we really work and bring in the community. We work with Doors. We help quite a few number of solutions across different area of TRL, as you mentioned, this concept of technology readiness level, and also across the different potential usage in blue economy sectors. And we also engage with investors, which is what I want to focus now. And I'll try to catch up because maybe we're a little late in time. I try to be brief. I don't aim at being very detailed, but passing a few concepts. So the first concept is this. So we've seen fantastic technologies and solutions and how Bridge managed to scale up at the level of TRL, which is the colorful green, yellow, red, purple in my slide, 9-step process that you illustrated in your solution. But my point here is that, and that's quite also clear in what you present, that once you have the solution, actually, if you look at the right side of my screen, there's this other concept, IRL, and just to load the audience with acronyms, but basically this is the investment readiness level. Almost starts when the TRL stop, in the sense that once you prove and you've actually can demonstrate that you have a technology, then the real challenge is, and what investors want is understanding how you make a business out of that, which is not necessarily the ambition and the competence of researcher, but very often is where researcher happen to be, because once you have your technology, you find out that you can make a startup, a spin-off, and SME, etc., etc. But just to say that, what then will be the next step for this solution is to understand the business model. Then business model canvas is one of the jargon and tools to structure that. But basically, as you see there, is number from 1 to 9 there as well. But is this orange depiction where you really look on the right side, you look at your end user, your customer, your channel. On the left side, you look at your partner, your internal structure, the cost structure, the activities, and the core is this central value proposition that you put forward. Then, of course, all of this is what you need to think about, and maybe you didn't think of when you were developing a solution, because your focus, as you demonstrate, is really producing valuable technology for valuable problem. But looking at how that can be used is a starting point, and you all rightly point out of some possible users. But the thing is that when you want to engage for getting money, then people will ask you, well, okay, this descending 1 to 9 again level of investment readiness. So, okay, what's your overall business model? What's the market size? What have you validated your problem solution, and have you tested your solution with sample of users, which is a minimum viable product, another jargon, but just for you to say, and what's the market fit? So really looking at the other side of a coin of the technology, and usually to do so you need money. For understanding and grounding a business out of a technology, it's effort, it's time, it's dedicated people, is expertise needed. So usually what we've seen in the Black Sea Accelerator is that once you have a great technology, then you need to have support and money to set up, understand better the market, understand better the business. And the thing is that, and the point I want to make is that maybe you don't need a lot of money, but you need a very clear support and technical advice, etc. So typically one tends to go to investors. Then, okay, what's the story for private financing in venture capital and investor in practice? So on the left top side of the slide, you see all this relation between corporation or like government, large bodies or public bodies that provide money to entrepreneurs to foster ideas and to move on and to develop their business model. But they do that on the basis of this business model canvas, business model ideas. And then venture capitalists engage with entrepreneurs and challenge their business model to see whether they can get revenue out of that by trading ideas with money. Usually supported by private investors. And then the next step is going like in an IPO, so in a public offering, and maybe quoting on the stock market, etc. But these are large profit makers. So all this to say that there is this process and there are these actors, and actually there is money because and I added this arrow between government and private investor on top left. It wasn't there in the chart originally, but government tend to give money to investors to incentivize their engagement in area they think are area with an important social environmental impact besides of financial one. And there are also a wide range of investment support mechanism to help technology provider and startup or spin-offers or SMEs too, or scientists to really move ahead in the investment readiness level. So scaling up from what is called pre-seed, so helping really developing a business concept, to creating the prototype, then developing business plan, and really having a large increase in size of the market, which is the table I put on the right of the screen. And of course, it's early growth exit stage. So these steps in the growth of the business are all related. And once you enter, then you're supported. But the point is that all of this imply that you're able to put down a business model, reflect on the market, have a market analysis, test your product with a range of different clients, and so on, which again requires money. There is an attempt to bring investors towards you researcher or us researcher or startupper is this way of de-risking. So de-risking means that for investors, offering money is a risk because the investors, of course, are market-based operators that lend money in return of future profits, let's say. And if some areas are not very certain, if some countries are a bit risky, or if some technology is not very mature, or the application of that technology is not very mature, as in the case we're discussing, the investors tend to be shy because it's risky and they don't have the certainty of the return of the investment. This is why public debt and grant and public money is used in this blended finance, and not the jargon, but basically it means mixing together, as in a cocktail, public and private financing to really try to bring money to encourage investors to come in area where risk is lower, and they might have less return. This is the example of the structures that I put in the figure on the right side of the slide. Sometimes public money is used to ensure coverage of risk for investors up to a certain level of capital. So as a government or European Commission, I give some guarantee for investor that, I mean, if you really get a loss of X%, I can cover that. Don't worry. I mean, up to that, I will cover you, and then you will put your money. But it can be done in very different way. Public money could be used to pay some technical assistance facility so that some expertise is mobilized to support the enterprise, the startup, the scientist, to structure their business, to be sure that it will be profitable, etc., etc. This is what, for example, EIB does. They do that with a recently promoted fund for blue economy in the Mediterranean, for example. Or I give you an initial grant with no cost, and then after that, investor come. So just to say that there is a very sophisticated environment to allow money to go to early stage startups or scaling up solution, like the great one we discussed. But my point in here now is that in any case, there's an asymmetry, because usually, and this is just a sample of a Blue Investor report. It's an investor report in the blue economy that has been promoted every year, I think. This is for last year, in fact. And if you look at the column of ticket size, which I highlighted in blue, meaning basically what is the amount of money, minimum and maximum, that investors and funds lend to give to startuppers to help them grow and then getting some revenue. You see that, well, there's an exception maybe in Catapult Ocean, but in general, the amount of money, minimum amount of money that investor give is quite high. Because in our experience, for example, with the Black Sea, and most likely that will be the case of also of your solution, solution wanted maybe 100K, 200K. I mean, 500K was really a lot to needed that to test the market, to understand the business model. So to do all that is needed to then be appealing for investors. And this is too little for investors. They really struggle to put little money there because they want to see return, and they need to have a minimum amount of money of investment that they give to ensure the range of return they want. These are funds of 75 million, 40 million, 200 million. So they look at large scale. And that's a problem that we see, because I think also in your case, you would need some smaller amount of money without any payback, maybe, and grants to really develop the business model, market analysis, and engage with the users you want. Also, and importantly, you all mention, and we all mention, public authorities as possible users, or the more direct user that we will see for the adoption and uptake and usage of this great solution. And because monitoring of quality of water is important, you mentioned, for some authorities, for local agencies, etc. And that's a different type of problem, because usually public procurement, and rightly so, to avoid corruption, to make predictability, to avoid loss of public taxpayer money. It's a very strict procedure that requires being very clear of what you are asking when you are you ask some supplier to procure you, or you're buying as a public authority some solution. But here we are in a stage where maybe public authorities are aware of, are aware of the problem they need to do, or they are aware of some sort of area of solution, like, we need to monitor better our seas at the level of pH, at the level of the ecosystem, etc. But they might lack the capacity of screening, understanding, and have a better, great view of what exists, and really identifying the perfect solution that they want for their needs. And this is where like innovative procurement comes in play, because if you look at the figure on the right side of the screen, then the commercial procurement, so the normal procurement is when you really know what you want and you make a call. But all the pre-commercial procurement, also known as the procurement of innovation in a way, really start much earlier. So and this is something regulated at the EU level, used at international practice. So it's nothing new. It's nothing just invented. It's been there for a while. It's just difficult maybe to understand by procurement, by public authorities, and it's maybe for them a bit risky to engage because they're not very sure on how to do it. But there are ways for public procurement and public authorities to engage, for example, with all your solution and start really from a zero or one phase in the pre-commercial procurement, where you really ask a number of suppliers to come to you and show what exists. Like, I need this, I need to monitor this. What's there? And you can make as a public authority a call for that, and you can budget that, and you can even go earlier on, like consulting on, well, this is my need. How can I do that? I don't even know. And then phases to phases, almost accompanying what you've been doing, and you feel like next step. As an authority, I can bring all this solution and help them with grant and public money to prototype and see what's best and what fits best my need, and then go to field test. And finally, I have the understanding of how to really pay for those solutions. And in doing so, not only as an authority, I'm able then to buy innovation and real innovation that fits my need, but also I'm kind of pulling local ecosystem actors, because I bring together new solution. I bring together technological provider with potential users, including myself, and the companies in the area that I work in, that is under my responsibility, and I help the system to scale up and develop together innovation. And in doing so, all these kind of reference to training, understanding, better, greater awareness of what exists or what could be done can be scaled up at the territorial level. So in the sense, there are a number of potential instruments at disposal. But what we see is that, and this is a relatively common situation still for innovation, particularly in the blue economy, but certainly still in the Black Sea, there's still this mismatch between the supply of technology available and the demand and the needs of that technology. But there's a lack of mechanism, including maybe financial support, for really bridging these two, bridging like the project. And we've done a lot in the project. I mean, and the Black Sea Accelerator also pioneered this approach across, together with doors across the Black Sea. But there is still this fragmented situation where the financing sector at the local level, at the country level, but also the regional level, public operators that are both financing innovation but need innovation, and the market at large are still kind of fragmented. And this is where there must be a greater push to support that. Again, there are opportunities, there are ways, there is also financial availability, but working together at the ecosystem level is needed. And this is also what we want to do and I'm closing here, Mustafa. And this is what we want to do in a future next brainstorming and roundtable for Bridge, that bring in the different funds available at country level, the innovation agency, business support center, and try to understand what exists locally, how can that be tailored further to the blue economy, and how different operators and different elements of the innovation ecosystem can work together better, so that you as a solution can really know exactly where to go to access the financial support you need to move from technology to a business model, and in that way being able to attract more investment, and also being able to provide a wide range of regional, international stakeholder and operators and public bodies with the state-of-the-art technology that we are developing. So I don't want to depress people in this, but there are opportunities, but it's really a struggle that we should overcome collectively in order to really create this awareness and cooperation between finance, public and private operator. So that's the message, and we'll be glad to see what you all think about this and what you suggest.
Thanks a lot, Matteo. Really excellent. I mean, it's the whole ecosystem of, from proof of concepts to proof of businesses is really complex. But from a researcher point of view, we need to do more from our side to understand this complexity and work with people like you more often, because sometimes we are also saying like, oh, nobody's taking up our technology. This is very important, but nobody's using it. But there's a lot to learn from each other to move these things further. But already, I mean, there are so many opportunities and mechanisms. It's obvious there are different funds. So beyond this classical funds, there are different investor types, and there are investing platforms which I'm sure they are underutilized at the moment, especially from academia. But with activities like this, we are trying to make these opportunities also more visible. With this, I don't see any questions yet in the chat, but maybe we can also give a short opportunity to the co-leaders of VP7, Patricio and Frederic. If you want to add something, please. I see Frederic's camera is, or Patricio, yeah.
I
Please.
can start with just a comment first. I mean, very interesting session. I think, I mean, the highlights of the technologies that have been shown, I think have a big potential for scaling up. We have been there involved, as Cremena mentioned, in some of the development for the acoustic solutions and jellyfish monitoring, which I think has a potential. As Matteo mentioned, there is a mismatch between the type of solutions investors would like to invest on and the type of needs that at this stage we have to make stronger proof of concept, and at the same time not to focus on the specific solution we want, but keep the flexibility to explore maybe out of this innovation loop other possibilities for products that can be used as on the market. In Bridge, we have tested this idea of the accelerator. Matteo presented that. I think the next phase will be to test the idea of an incubator, going a little bit earlier in the phase of development and really creating not only a virtual space, but really a physical space where the experience of the forum that we also have produced in Bridge, where investors can meet, innovators can meet, academia can meet, and a physical space where things can be tested and proved real time. I think that will be something new, something great for the Black Sea, and it's something that maybe the European Commissions, but also private investors might actually think as a good opportunity for generating ideas. Yeah, that's it.
Thank you, Patricio. Frederic?
Maybe, yeah. If I just can add on that and leave the floor to Fred. And I think my point was also that absolutely that, but also find a way to bring in local financing actor like impact investors or foundations or all those financing actors that exist, and try to bring them, because they do stuff in maybe other areas. In Bulgaria, there's a lot of fantastic stuff, but not vertically in the blue economy. And this is a common perception, like that no, we are general, but then being general, you ended up in digital, in whether we need to bring impact investor and foundation money and grants to fuel that type of incubator or accelerator, because then you need money. I mean, you can give advice, but you need money to pilot, test, and do little things. And this is where we still don't have access to such money. Sorry, but Fred.
Thanks. Yeah, Fred?
Yes, well, everything has already been said, I would say. Maybe the important is also to consider to which extent Maritime Institute can also develop spin-off or which can be key actors, because as you see, it's not only a matter of technology development, but also a matter of targeting market and for which business has to be addressed. So I think it's a good way to be considered, and I would say that it exactly follow what has just been said by Patrizio about the incubator, in which, for instance, spin-off or incubators, which could be provided via make the link with this market could be leveraged for that. Keeping in mind that the solution which has been developed so far by Bridge are Black Sea oriented regarding the technology and scientific needs. Sometimes they have to be considered to be scaled up, to be valid for other sea basin, for the Med, for instance, but not only. And keeping in mind, at least not that there's still being competition in development. The solution which have been developed, of course, answers some scientific, even policy needs, but there's also market to be considered. So think first of all not only on solution, maybe on services which can be developed, and maybe in which way they can be scaled up. I think that Bridge BS was a great opportunity to leverage solutions, meeting, as you said, and I would fully agree, meeting Black Sea needs, but in which way they can be scaled up. And I would say it is the benefits also of having partners from all the sea basins, from the Med, the Atlantic, from the North Sea and the Baltic, with engaged in Bridge, and for which we are merging and converging our competencies and what we can and skills in order to meet the needs, but also to develop science and potential business. And there's big opportunity. Thank you.
And I wonder, Mustafa, and all, given that this is the majority of attendees are related to research, and to what extent maybe university also should consider slightly changing the business model, not moving away, of course, from research and publication and patenting, but maybe consider playing this role of aggregator of financial resources for acceleration. It's something that we discuss here and there. It's something maybe the DTU does it with their work on incubation, but maybe there's also an opportunity, a challenge, but also an opportunity for university to enlarge their positioning and play a role in that.
Thanks, Matteo. Frederick, I also reiterate your comment on the need for services and tools. So most of times the users or investors, they may not be interested directly in the specific technology we are developing, but they may be interested in the solution, the integrated solution with all the digitalization, visualization, maps or projections. Actually, that's the type of thing they're interested in. And in Bridge Black Sea, that's exactly what we are trying to build on. Tools, digital twins, also more smaller tools on adaptive management, which will all be highlighted in the third webinar in September. I see we have a question in the chat from Betül, one of the PhD students, to Nina. Nina, if you are still here, so is there any sea basin where this is applied until now? We already showed actually the application in China. And what are there any other limitations for the Black Sea other than the lack of a library so far?
According to the first question, as far as I know from my research, it has been applied for research purposes in the Mediterranean and also some other basins, but mainly for research purposes. But when we were at the training for Site2Sense and EasyClass software using, the lecturer explained that in the Netherlands, the authorities also are using this approach for continuous monitoring of water quality. So there are some examples that authorities have been benefit from this approach. I think there is a big future, both in terms of research, in terms of authority usage, and of course, even private industries, because even though in the Black Sea, the aquaculture is not so so well developed. Let's say there are still some aquaculture farms, and probably in future there will be even further interest in this this industry. So definitely there will be a future in this technology to be used by different type of end users. What was the other? Yes, as I said, it is
limitations, yeah.
yeah, it is good for continuous data, for real-time data, for early warning system. And about the limitation, no, I cannot say that there are specific limitation. On the contrary, the results were, even though they are preliminary, they are for now pretty good. So I can't say that based on the results, there are some specific limitation to be applied here. Thank you very much for the question, Betju.
Thank you.
Any other question from our audience? I'm looking at, we have a really diverse range of audience from different countries, different sectors. So please feel free to pose anything or any comment. You can ask very simple things as well. I see we have also many young scientists among us. Anybody raising hand? I don't see it. All right, so looks like things were quite clear. We tried to convey our work in a simpler manner. Of course, it's challenging, especially for us scientists, to be able to do this. But as we progress in the Breach Black Sea project, as we progress towards our final event in Brussels, we will further refine our message and integrate what we discussed today into really robust and credible pathways for innovation in the Black Sea. And as also Nina just mentioned, there's a big potential for even for a tool such as phytoplankton monitoring. I mean, many communities along Black Sea, they are suffering from harmful algal blooms, for example. So all these technologies, they have really big potential for upscaling. But as I said, we need to work more with innovation side, with experts like Matteo and Fred to really build more robust pathways towards this. So with this, I thank everyone on behalf of my partners, on behalf of the project, and keep in touch. And we are also looking forward to seeing you in our next webinar in September. So time will be announced very soon. Thank you. Bye.
Thank you. Bye.
Bye-bye.
Thank you. Bye-bye.
Bye bye.
Bye.